Assignment 3, page 3. The first problem is to find the sum. Given here, this is an infinite geometric sum. So the formula for the infinite sum is the first term over 1 minus the common ratio, as long as our ratio is less than 1. And notice that the ratio of 2/3 is indeed less than 1. So we're acceptable and allowed to use this. Okay, our first term is what we would get when we replace k with 1. 2/3 times 3 would be 2 over 1 minus our ratio, which is 2/3. So we get 2 over 1 minus 2/3 is 1/3. And 2 over 1/3 is, of course, 6. So the final answer here is 6. For the problem in the top right corner, we have 1 to infinity of 7 times 1.2 to the k. Notice what's the r this time? R equals 1.2, and that's not less than 1. So this diverges. That's our conclusion when our ratio is not in the right interval, right? Because this means our terms are going to get larger and larger and larger and larger. Our sum is going to diverge. So how about some word problems? Suppose we put $400 in the bank at the end of every month. Calculate how much money would you have after 20 years if the account earned 4% interest compounded monthly. Okay, so that 400, if we think of this over 20 years, 20, how many months in a year is 12? We're going to have 480 deposits here. The deposit that we make 1 month before we look at the total. Right, we're putting it at the end of every month. So at the end of that very last installment, that $400 would just be put into the bank. That's 400. The installment before that installment would have received 1 month's worth of interest. So it's going to be a value of 400, 1 plus that 0.04 interest rate divided by 12, because it's a monthly interest rate, to the power of 1 over 12, or sorry, to the power of 1, because this would only be 1 month's worth of interest, and we only get 1 month's worth of interest on that $400 deposit. Plus 1 plus, how about the one that was given 2 months from the end? That's going to be 0.04 over 12 to the power of 2. How about the one 3 months from the end? 1 plus 0.04 over 12 to the power of 3, etc., etc., etc. And we're going to be doing this for 20 years. So the one that we did today, let's see, if we look at this as we're saying this one right here was put in at the end of the month, so it didn't have any interest. That means technically the one that we put in at the very beginning would have 479 interests, right? 400, because we're only putting it in at the end of the month. So if we count time as now, like I wouldn't be putting the money in at the beginning of the month, I'd be putting it in at the end of the month. So this one's going to be 1 plus 0.04 over 12 to the power of 479. Notice this is a finite geometric series. So we end up getting what as our final total at the end? S of 480 deposits here. 480 deposits, where our, let's see, what do we got? First term was 400. 1 minus the common ratio is this 1 plus 0.04 over 12. We have to raise that to the power of n, so that's going to be to the power of 480 inside of the parenthesis. Sorry for that little mess up there, but that's inside of the parenthesis, all over 1 minus the interest rate, or 1 minus the common multiplier in this case. So that means we will be calculating, this is definitely going to be a calculator problem, 400 times 1 minus 1 plus 0.04 divided by 12. We're going to take that and raise it to the power of 480, and we're going to place that over 1 minus 1 plus 0.04 over 12. If we close that all up, looks like we're getting 472,784 and 54 cents. So about $472,000, which if we just calculate very quickly, $400, 12 months in a year over 20 years, we're only putting in about 100,000, but we're getting almost 4.7 times that, 4.5 times that due to the interest compounding. Final one on this page is a ball rebounds to a height of 1/3 of the height from which it was dropped. It is dropped from an initial height of 6 feet. That's a note to myself, I gotta fix that. How far will the ball travel in total? So the ball is dropped from a height of 6 feet, and then it drops and bounces up, and then drops and then bounces up, and then drops. So it looks kind of like this. And if we draw it like this, then you can see that there's two infinite geometric sums that are going on here. One is the downward motion. The downward motion drops 6 as an initial value, and then the second one is 1/3 of the original. So 1/3 of 6 would be 2, etc., etc., etc. So the downward motion would be an infinite geometric sum that has first term 6 over 1 minus that common ratio of 1/3. So 6 over 2/3, which would be equal to 9. The upward motion, the first upward motion is the 2, but it also rebounds back up to 1/3 of its previous height, so that'll also be 1 minus 1/3. 2 over 2/3, and that seems to be a total of 3, if I'm not mistaken. 6 over 2, yeah, that's 3. So in total, the motion downward is 9, the motion upward is 3, and so the total motion ends up being 12.